Hello and welcome back to another video of Grokking the Coding interview series. We are looking at the sliding window pattern, and in this video we'll have a look at fruits into baskets problem, which is classified as a medium problem. Let's have a look at the problem statement. You are visiting a farm to collect fruits. The farm has a single row of fruit trees. You will be given 2 baskets and your goal is to pick as many fruits as possible to be replaced in the given baskets to be placed in the given baskets. You will be given an array of characters where each character represents a fruit tree. The farm has the following restrictions. Each basket can have only one type of fruit. There is no limit to how many fruit a basket can hold. So it is important to note that each basket can only have one type of fruit, and if we have 2 baskets, it would mean that we can at most have 2 distinct fruits in our baskets. You can start with any tree, but you can't skip a tree once you have started. So it should be a contiguous sequence which we are putting into the basket. You will pick exactly 1 fruit from each tree until you cannot. You will stop when you have to pick from a 3rd fruit type. So essentially we have seen this problem previously where we have to identify the longest continuous subarray with distinct k elements, and here the k is actually 2, so we cannot have more than 2 distinct elements in that subarray. And we also see the examples here. So we can put 2C in one basket. So the longest possible subarray here is CAC, and in this case it'll be this one. So we already know the k is 2. Then how would a potential solution look like at this point? We'll actually take a similar approach where we will have a hash map where we'll keep a track of the number of distinct elements in the basket. As soon as the length of that hash map increases the k, we will try to reduce. So we have had an implementation. Let's try to implement this solution and see if it works according to what we are expecting. We'll again use the sliding window approach. So we'll first have a hash map, which will be a dictionary in case of Python. We have to output the maximum length of such a subarray. We also have a window start. Both will be initialized to 0. Do we need to get the current length? No, because we'll just use the window start and window end in order to fetch that. So at this point we can start our iteration of the array, the fruit array here. So for window end in range, or window in range len of fruits, so what we are essentially doing here is we are going through each element, or we are going through the index of each element in the fruit, and as the first step we want to add it into the hash map if it is already if it isn't already there, or if it is already in the hash map we want to increment that by 1. So if fruits window and in fruits fric, in that case we just go ahead and increment it. else we just initialize it to 1. Just let me see if my indexing is correct here. Yeah, of course it's not. So this should be an index into the fruit frequency. And we initialize it to 1. So at this point we are keeping a track of how many distinct fruits we have in the hash map, and if the length of the fruits frequency is more than k, and k is 2 in our case, we want to make some changes, and the changes will be more like we want to reduce, or this should actually be while. So while we have more than 2 distinct fruits in the basket, we want to keep removing fruits from the basket until we only have 2 distinct fruits. So so essentially at this point, what we want to do is this should be Windows start, equals to 1, and this should actually be Windows start, because we want to shrink the window essentially at this point. If this is already 1, then we go ahead and remove it simply. Else we just reduce it by 1, and we will keep doing it until again the number of distinct fruits in the basket is less than or equals to 2. And once we have removed all the elements, we'll go ahead and get the max len, and the max len will again be window end minus window start plus 1, after we have removed all the elements which we did not want into the window. Okay, and this actually would return simply what we are looking for as a solution here. So let's do a dry run, and like if you observe it, it's very similar to the previous implementation which we had, and just how the problem is framed is different, and we have to identify that a k in this case is actually 2. And let's see, our answer was 3 and 5. In case there are, yeah, we'll run it and see in case there are any evident errors. Have we not initialized that? Okay, this should be max len. Okay, let's see if there are any other errors potentially. So our output is 5 and 6. The actual outputs are 3 and 5, which is the case because we know this, and this is actually what we are looking for. So let's try to see where the problem might be. And also we are not updating the Windows start at this moment, which we should for sure do. So whenever we get into this else statement, we want to update the Windows start. Okay, this should potentially address the problem which we have. Actually, no. This does not address the problem which we have. So let's have a look at what might be wrong here. So we also want to increase the Windows start here. We actually want to increase the Windows start while we finish every while loop, right? Either this condition will be met or this condition will be met, and we'll increase the Windows start as we keep removing the elements and we keep shrinking the window. Yeah, this sounds much more reasonable from how I see it. Okay, let's see. Yeah, okay, so seems like we had to update Windows start irrespective of which condition we are. So as we go ahead and iterate, or as we go ahead and remove or shrink windows, we have to keep updating the Windows start, and it would lead to the optimal length or the max length which we are looking for. Let's quickly speak about the time and space complexity of the implementation. We are again having a hash map which at max stores 2 elements or k elements. So the space complexity will at max be O of k plus 1, as we'll be removing the elements afterwards. So O of k effectively, or in this case, because we have a restriction on k which is 2, so it'll be O of 2 either way, or O of 3 either way. And when it comes to the time complexity, it'll again be O of n on the outside, and we also have this inner loop which at the worst case can be n, so it will be O of n plus n, which will lead to O of n. So the time complexity in this case will be O of n. Okay, so I hope you found this video useful. Please feel free to reach out in case it was not clear, and if I can improve anywhere. And until the next video, have a great day.